Morning, morning. Now we are starting our final day of the school, and let me make a few announcements. First, the group picture of the participants will be taken during, not during, but before the lunch, near the digit building. So please, everyone, after the lecture of Konstantin Gergely, please make your way to the stairs of the digit building. During the closing ceremony, we will have a discussion about the future of artificial intelligence, and everyone is free to come and listen and to maybe participate. And also during the closing ceremony, there will be the presentation of hackathon solutions, and these presentations will be organized in the nearby rooms. The number of rooms are posted on the site in the hackathon sections. Yes, and also you will be given T-shirts with the logo of the school, and I think the T-shirts will be available either during the first coffee break or maybe during the closing ceremony. So, yeah. And now let me introduce our first speaker, Professor Tamas Gergely from the Laboratory of Applied Logic in Hungary, and his lecture, An Alternative for Artificial Intelligence, Conceptual and Formal Theory.
Okay, should I use a mic, or it's okay in that way because the microphone is too hot? All right, should I use it or? Очень громко, можно делать его тише? Hello, good morning everybody, it's okay? Fine. Today I would like to talk about the conceptual and formal theoretical aspects of a newly proposed approach to artificial intelligence. If we see about the situation what are living in, that we see that everything around us is smart, intelligent, cognitive, except humans. And so, and if we can find many devices which really in some sense intelligent, or in other sense smart, but if we are looking into the details, then we see that they are much more artificial than intelligent. So this is, we ask for us the question, what is artificial intelligence really is, and how can the situation today be characterized. So what I accept from a field, that it should have in some sense a conceptual apparatus with scientifically well-based methodology, and if it want to support somehow intelligent activity, it would be nice if he would have a generally accepted philosophical foundation, for example, in a form of appropriate epistemology and ontology, which would help to respond to challenges and to respond somehow adequately to the new challenges, of course, what we have from the environment, And this is what we would like to see in the field of AI, which unfortunately today we can't. And of course, if we see the situation today, that we can see that it's nothing else that a conglomerate of techniques, methods, and various research and development directions. For example, machine learning and especially deep learning are the most commonly used methods in this area. And of course, artificial intelligence covers many technologies and realities that lead to misunderstandings about what it really means. For illustrating this statement, I took a diagram from a recently published book on data analysis, where they try to explain the interrelation between artificial intelligence, machine learning, and data science. So this means that there is a big conglomerate of different areas which for some reason can be bounded and telling that this is artificial intelligence, this is machine learning, this is data science. But anyway, they are very interlinked, and it's very difficult to tell that this is only a pure artificial intelligence. And this is why very often we ask the question, what is real artificial intelligence? And many of the scientists tell that we have to reach a certain position in the future, an ideal state, if you like, where the real artificial intelligence will appear. What we propose an approach, the target of which is to provide a technologically well-equipped amplifier for intelligence that would be able to act as a genuine problem-solving companion, understanding and responding to complex problem situations. That is, in this approach, AI is not artificial intelligence, but an amplifier for intelligence. And this means that artificial intelligence as such should be a symbiotic partner, not a replacement. And to illustrate this statement, I would like to use the paraphrased drawing of Escher, which show this symbiotic partnership between human and artificial agents. So what we propose has the following long-term vision, which consists of developing theoretically well-funded, coherent, integrated theory, technology, and design methodology for a new computation paradigm, the so-called cognitive intelligence cooperative system, what is short in COIOS. This is the pseudonym of our nickname of our proposal approach. And in that sense, what I mentioned earlier, it aims to support the collaborative intelligence where humans and AI systems are joining their abilities. To reach the goal, what we have this methodological schema here, which starts with a triangle consisting of philosophical foundation, logical mathematical foundation, system theoretic foundation, and the result what we'll get in that triangle will be used for developing the engineering foundation and then to making the computational realization. And some details about these methodological steps are written on the right-hand side of the name. So, for example, I don't want to into details because some of them will be discussed later on, but only to show you the entire picture, it's important to have this here. And what I would like to emphasize only that having this methodological aid or guide for developing the approach, we have a prehistory which helps us to go through all these stages. And before going into details, I would like to summarize what COIOS systems should satisfy as properties. So first, as I mentioned earlier, it will be able to act as a genuine problem-solving companions that can understand and respond to complex problem situations. And it's very important other things is that the COIOS system could serve as a partner system for a cooperative functioning with a human agent, or they also can be autonomous in a well-defined problem area. So this doesn't mean this collaboration every time needs a human partner. It only means that the system has such abilities which can be used even in an autonomous regime. So turning to the foundations and the vision of the COIOS approach, I emphasize the following pillars what we have here, and I think it's not bad. Okay, so we have 4 pillars here, and I guess there is something here which I could use. A pointer, I guess. It's on. Oh, anyway, so I start without it. So, oh, okay, fine, thanks. So we have a. Почему ты не хочешь?
Может, просто посильнее вот на это.
Понятно. Okay. So there is a integrated logic framework, which is really a logic mathematical framework for computing in general. There is a cognitive reasoning framework. There is a framework for cognitive data analysis. And the next is a framework for cognitive linguistical tools, which partially here is called capsule theory, which is one of the methods which were developed. And on the base of these pillars, which already exist, an integrated theory is under development actually, in such a way that it picks up the main characteristic and prospective parts and put it into a generalized integrated theory, which is a good background for developing the COIOS technology, on the base of which a COIOS intelligent platform will develop. At the end we have the ecosystem. And the main characteristic of this approach is it is open. Open in the sense that it can integrate and embed all the necessary tools what we have in the external world from very different areas. This could be algorithms, approaches, methods, and this is why it's a very useful tool set, can be involved into the technology provided by the approach in order to find the appropriate to the actual problem situations in order to be able to solve and decrease the actual uncertainties. So turning to the methodological phases, I would like to tell some words about the philosophical level, about the ontology. If we take into account how the external world exists around us, we can distinguish 2 big different set or conglomerate of events. One is the word of regular events, and the second is the word of extreme events. If we use the terms provided by Taleb in his book, The Black Swan, then the regular events, the word of the regular events can be called mediocristan, and the extreme events extremistan, but it's only a literate version of the same. But the main characteristics of these two types of words are the followings. The mediocristan, because it has regular events, it's more or less good for analysis, for providing appropriate predictions, to characterize it, and even to find appropriate models to working with it. We don't have the same situation for the events which comes from extremistan, where you have some extreme events which usually accurately couldn't be predicted, and very important things arise with them. For example, this is the case when you have to predict events from an unpredictable world. And of course, we saw some methods which can help even in this case, but I think it's not in this lecture now. But anyway, the main characteristics of the mediocristan events are the Gaussian distribution, which emblems this type of word. And the other word is emblems with Cauchy distribution. To illustrate what does it mean, I compared in this picture the two types of distributions, normalized in a symmetric way that you can see them together. And the red one is the Cauchy distribution, while the blue one is the Gaussian one. And you can see the main difference is that the tails of the red one much heavier, so even it's almost near to the infinity, you have events which could appear with the probability more than 0. And so now some words about the regular events. So when you speak about the word of regular events, even there you have three types. You have deterministic, probabilistic, or in some stationary statistics, stochastic, and the mixed situation where these two types of deterministic and probabilistic could be used together. And if you turn to the second aspect of the philosophical level, which is epistemology, the main characteristic of our approach, because it goes to that we characterize at two aspects the epistemological foundation. First, epistemology without cognizing agents, which try to characterize the knowledge in general and about the processes, how it can be acquired, how it represented, used, and managed. But even for artificial intelligence, in some sense, it's much more important to have the epistemology with cognizing agents. That is where we see how the cognizing processes appear in a cognizing agent, and what are the specificity of the knowledge acquisition, knowledge justification, what type of tools you have to use, what is rationality in the actual situation, and of course providing appropriate methodology for representing, managing knowledge and the corresponding information processes inside of the cognizing agents. And now some words about the four pillars what I mentioned earlier. So the first one is the integrated logic framework. The second, the cognitive reasoning framework. The third is the cognitive data analytical framework, and the fourth, the computational cognitive linguistic framework. About the computing framework, I would like to mention only one important thing, that it integrates different type of aspects of theory of programming, theory of computing, and also provides a unified theory for specification of algorithms, specification of programs. And at the same time, it can cover different programming paradigms, including imperative, declarative, and even object-oriented and other types of programming. The complexity of the theory which has been developed can be seen in this diagram, and I don't want to go into details, only I'd like to emphasize two things. First is that it has a very, very well equipped logic foundation, and it theoretically well-based set theory developed especially for this frame which is constructive, and in all the picture every aspects are constructive, which is very important for realization. As I see, it's not very good. The picture is not anyway. It's here is good, but there not. Well, the focus is not good. I don't know. Okay. And the first results of the boxes on the previous diagram were published in this book under the title First Order Programming Theories, because the first order foundation is a very important thing here, and of course constructivity is the other, in order to get a realizable end product of the theories. For example, the specification language which was given here is used, for example, for directly specified programs in a almost natural language, which could be afterwards executed. The second pillar is a cognitive reasoning framework, which is a generic unified technological and methodological framework for realizing different types of reasoning processes. And it's based on a special non-classical logical tool set, and, and it's very important that it can be used for various types of uncertainties and working in very different complex problem situations involving different type of reasoning components. And it starts, of course, from data analysis, and then it can be used, we can use different types of plausible, non-plausible, reliable, non-reliable rules for processing information. The main components of this framework are shown in this diagram, where it's very important box below, which shows that the theory also contains a very specific strategic level, which helps to collaborate with the environment where for the cognizing agent, this technology provides a collaboration with another agent, which could be a human or another cognitive agent in an artificial frame. So, and of course it's important aspect that the modification theory and the open cognitive theory, for example, which is the entire methodology with the theory, which is called quasi-axiomatic theory, contains all the information what we have in knowledge, what we get from data, and all the processing components, which could be different type of rules, for example, which we call modification rules together, which could be logical, could be statistical, could be fuzzy rules. So they are very, very open, even for embedding new ones. And this openness is a very important aspect, as I mentioned earlier, for each framework what I present here. And for example, as I mentioned, the cognitive reasoning framework can integrate plausible and reliable inferences together, and they can be interchanged during the process. And it could be probabilistic reasoning, could be realized approximate reasoning, where we use, for example, different type of fuzzy sets and possibility theoretical methods, or, which is very important, it can be used different type of heuristics and realizing heuristic reasoning. For example, one example is the GSM reasoning, and some others, if you like, the explanation reasoning. And of course, it also can use model-based reasoning. And the main advantage of the proposed formalism is that it can be used for formalizing and embedding any type of heuristics. And it is very important in the sense that when we want to consider a dual system, what is characteristics now for human thinking, where you have a slow and you have a fast thinking system, where the slow one is mainly based on heuristics, when they make some using analytical tools, they make some analysis, analyzing the situation, trying to find the appropriate methods for processing, and this is why it is a slow response to the events what happens and influences the intelligent system at the moment. And the fast one usually use beliefs, biases, and also heuristics, and it provides a very quick response without any analysis. So both type of thinking style could be modeled, if you like, and realized by these tools what is proposed by the framework. And the other important aspect, which is very important for us, because when we process data and process information, every time we look at the meaning. So this means we use a semantic-driven information and data processing. And the technology what we developed in that framework provides this if you like, so implementation in just in time, when you have the using the reasoning rules. At the same time, you can estimate their semantic meaning together with some justification of the obtained result. And the same is when you have the plausibility degree, which is also an important tool for checking how the reasoning process runs. The basic components of this cognitive reasoning framework were published in the book which is written by me and Professor Anstakov, and that's titled Cognitive Reasoning, a Formal Approach. Too quick. Okay, the fourth. I paused the third one somehow. Okay. From the third pillar, I mention only a very important characteristic what we would like to realize here. This is the realization of the process of data information knowledge sequence. That means that we start with data, we turn it into information, and what we can pick up from information into knowledge, we acquire, we take it and put it and compare with the existing knowledge. So this is the process what we all the time try to realize during each information processing. And all the methods what we use as a cognitive method of data analysis was selected in order to support this sequence process. And which very important here is that what we really use is a knowledge-driven, as I mentioned earlier, even here in data analysis, and which was the same in cognitive reasoning framework. And this is what, for example, in the cognitive reasoning framework, the non-axiomatic approach provides us, which is combined with this data information knowledge sequentialization in the sense that the data analysis is done with the hierarchical data science methods, and afterwards, time to time, it integrates with different type of plausible or reliable inference rules. And for example, here I mentioned one important area what we use here, and the methodology of symptom-syndrome network technology together with the syndrome analysis method, which we use in a very general sense in our framework. And the fourth one is the capsule-based cognitive semantics, which, as I mentioned, is a part of the cognitive linguistics. And technologically, we generalized the film was frame semantics technology, which was not good for our aim. This is why we modified it and generalized in many sense. I mentioned only some of them. The main characteristics of this approach is that the ontology capsule method provides a corresponding cognitive semantic for developing and supporting the natural language related situations, managing them, describing them, getting information from them. So this is and it also at the same time provides a frame where we can not only use information from text on natural language, but also we can combine with information from different types of channels like visual, audio, spatial geometric, and putting them together into one capsule, we have an integrated representation of the event what appears in the environment. And at the same time, it provides a very good modalistic independent semantic representation of the events, which help the cognitive computing systems to work with situations and problem situations just in time. And I mention only here two types of capsules, which are the main here. One type of capsule supports cognizing processes, the other supports the languaging processes. So cognizing related with the knowledge, that is, I use knowledge capsules, and the other is related to using the natural language, and this is why it uses so-called semantic lexicon, which related and reflect the components of the knowledge capsules. Moreover, in these capsules, some information about the language use also are involved, so it's very important to have some procedural knowledge, not only some descriptive one. And in the picture you can see how they realize that at the modeling level you have the abstract capsules which realize in two different types of interrelated systems, which are the knowledge capsules and the semantic capsules. Knowledge capsules support cognizing processes and the semantic capsules support languaging. And the architecture of the integrated system is shown here, that you can see the interrelation of the languaging and the cognizing processes and the realization of all the components, the different type of knowledge, the linguistic knowledge, the concept structures, and the knowledge about the world themselves, and knowledge about the environment could be integrated into one level and having a integrated knowledge representation system there. And we see that languaging helps us to start from a problem situation, which, as I mentioned, can be multimedial level. It can be visual, audio, and anyway it will be represented by appropriate language. And analyzing the language, we put and represent the content of this text into appropriate formal tools to have the cognizing process over it. And now some words about the integration and about what I mentioned earlier, that from the 4 pillars we pick up the appropriate components and construct a unified theory in order to go further. We have here 5 stages. First, what I mentioned is we have to select the perspective modules from the 4 pillars, and afterwards we turn to the second stage to develop the unified conceptual and formal theories that integrate the main relevant aspects of the theory of the pillars. So this is what I will tell some words about, and afterwards we will develop the technological components and go to the curious ecosystem. But the main point here that we in parallel develop, of course, we realize all these stages almost in parallel, because many interdependent situations appear which needs collaboration of all the participants in the same stage. So the main characteristic of the unified mathematical foundation, that is a transdisciplinary logical mathematical foundation which integrates 3 aspects here: the computing process theory that describes the computer world, the cognitive reasoning framework that integrates plausible, reliable inferences, and also, it's very important, the contradictory thinking processes. This means we should somehow working with the situations where the information and the data has some contradiction, and what we can do in that case is very important in order to realize the sequence of data, information, knowledge. And the third is hierarchy data science that provides the knowledge and semantic driven special data handling calculus. And the result will be get also by the methodological triangle here, it's almost the same what was earlier with the same components. The difference is that at the philosophical level we will have a very special formal epistemology, and at the logical mathematical foundation level we will have special mathematical tools which supports the foundation. So this is the constitutions, which I will tell some words about it. We provide a mathematical definition of cognitive computing and give some methods by which we can analyze it. And we have a very special specification theory which provides appropriate specification languages for describing the situations with uncertainties, that is to describe and specify the way out from the problem situations. And the system theoretic foundation here provide very special tools from cognitive intelligence theory, problem solving theory, which should be transformed and developed further according to the request what we have for COIOS, and in general a special theory of system. And sorry. The mathematical foundation has the following picture here. So it's a very special theory which is called constitution theory, is developed, which is in the frame of category theory, and we saw that there is a special type of compact constitutions which are useful for reaching the state of cognitive computing. And further we developed a first order logical foundation, and which supports this level where we have two types of set theory, which both are constructive. One is just finite set theory with atoms and classes, and this is the finite set theory with atoms and co-classes. And we consider that here data and codata together, and in order to have some idea what codata is, I mention only that, for example, knowledge in an intelligent system can be represented and handled by codata and not as data. So when we speak that in a knowledge base it's almost the same as a database, it's technically is true, but from theoretical point of view they are different, and they should handle in a different way. And on the base of this foundation, the computing theory can be provided with cognitive reasoning tools and also with cognitive data analysis. And I mentioned here that in parallel the specification theory can be driven, which has for all levels appropriate toolset. And then on the base we define the cognitive kernel, which is the basic components for defining cognitive computing. So this is the entire architecture, if you like, of the mathematical foundation. And only to show some ideas how does it work, so the constitution theory starts with the definition of so-called preconstitutions, which is defined here. I don't want to go into details. And then on the base of the preconstitutions, the constitutions are defined, which provide a special tool set for working with different constructive, in some sense, objects. And then what I mentioned earlier, there is a special class of constitutions which are called compact constitutions, which has a certain property with respect to the constitutions in general, and this property allows us to be closed in some sense and reflect to the appropriate specifications what we will have further. And this is a very important aspect when we can reduce the components in order to have some refinement, and the refinement goes into the direction that it will go to a constructive realization process at the end. And there is a main theorem which means that there exists a minimal constitution which covers some problem situations where it provides appropriate tool set for working with the appropriate computational processes inside. And one example, for example, of these constitutions is the first-order logic in general. So the first-order logic is an appropriately constructed constitutions. So these also show that this term is very general, and almost all the necessary tools what we have and what we should develop further can be done inside of this theoretical framework. And for example, about the generality of the proposed programming computational description part, that it can describe all these types which are very important in the present development areas of artificial intelligence, the granular programming, which is based on the rough sets theory, and probabilistic programming, which was developed specially for writing in an easy way different algorithms and programs for machine learning. And even the main ideas and different types of machine learning algorithms and methods can be expressed in the same framework as well. And some words about the cognition kernel, which is the basic element of the cognitive computation. This does provide a generalization of the so-called information theory that with the corresponding inference and reasoning and inference systems. And here information theory can be understood in the style of Devlin and Barwise. Barwise and Perrin developed the so-called situational semantics for natural language, mainly for speech acts, and this theory was used by Devlin developing his information theory with so-called infons, and all this technology can be embedded into the proposed framework here, and it goes further with in certain sense in order to get not only descriptive facilities but also realized in different types of computational models. And then this is the modification theory, for example, which involved this type of possibilities, and the knowledge components together with knowledge semantic-driven special data handling calculi will be also involved in this cognition kernel. So the main components of the cognition kernel can be seen here, where we have the infos and information, as I mentioned, have the situations in a generalized sense from the Barwise-Perrin sense, and the technology, which is the equations, co-equations, which are the algebraic logical construction, which defines different components of knowledge, for example, of situations, of informations, and the main things that it use these equations and the solutions provide you different types of fixed points. Least fixed points, greatest fixed points, depending on the situation. And having the knowledge, at the end we will be able to realize cognitive processes at the end. And the methodological looking ahead, which consists of the specification theory, what I mentioned on the right-hand side, it was in the diagram a special block which has these 4 components of specification. We start with specification of the program functions, of data environment, specification of knowledge, and specification of the task or the problem which should be solved. And then at the end we will have a constructive specification theory together, which is based on this specification theory, which has this type of sub-theories, and out we have a declarative language for cognitive computing at the end. So declarative in the sense that you can describe things which can be realized in some sense in the cognitive computers. And to seeing what type of computation appears here, I would mention the church thesis, which is a very important thing here, because we really expect that what we intuitively think that it's cognitively computable, that is, for example, we prove something and it can be realized that, okay, it would be nice to realize with our cognitive computer. But unfortunately, it's not the case, as the main point here is that intuitively cognitive computable statements are not cognitive computable. But there is something which is good, that even the intuitively cognitive computable statements are cognitive computable by a very special cognitive computing machine which contains oraculum. So this means that we can, at the cognitive level, really realize different type of computational processes if we have an oraculum which could be some added information from outside, which is the oraculum, and it can be in the role of oraculum can be another artificial collaborator or a human agent. So some important specificities of the proposed approach is shown here, and I only emphasize two things, that by using these cognitive computers, in the sense what I can define in a mathematical level, it is important we can develop such type of creative space where a collaboration of the components, I mean the human and cognitive and artificial cognitive agents, can be collaborated in that way that they can even realize in some novel sense insights. So these are important aspects of this approach. And there are some comparisons with the usual approach to artificial intelligence, and I mention only some of them because my time is over. And the main is the foundation, where in artificial intelligence the foundation is usually fragmented. And this means that depending on the aim what the certain researcher develop, it provides some type of foundation, either philosophical or mathematical, but the field itself hasn't a unique foundation. In contrary to this, in COIOS we have this. And the main difference that artificial intelligence many times aims to replace human agents, and instead of this, COIOS want to enhance the abilities of human intelligence by appropriate artificial tools. And for example, at the hardware level or neurophysiological analogy, artificial intelligence with the connectons, that is meant with neural sets, are characterized. In our case, it will be a multi-level network together with some meta stages where we have some, if you like, some notions and other type of more abstract things. And what is important. Okay, so there are some other characterization which are important in the sense, for example, in the cognitive psychological issue, you have a convergent processes consisting deduction, induction, abduction in some sense to integrate them. In COIOS, you have a very special, very general interrelation between different reliable and plausible reasoning, among which, of course, we can have such type like deduction, induction, abduction, but many others too. And the Okay, so I think this was the main, most important ones, and then I would like to finish on it, and if you have some questions, I think we have a couple of minutes for them.
Thank you very much.